All right, let's begin. So just to reiterate what I said in our class on Wednesday, you should have a laptop computer with you so that you can access Microsoft Excel for the remainder of the semester. We'll use it probably 3/4 of the time. The next homework assignment's due on Wednesday of next week, and today we're going to continue looking at spreadsheets and how we can use them to calculate economic equivalence. So does anybody have questions about the announcements before we continue? All right. So let's just review. Equilibrium, or balance, is what we're looking for in order to determine the rate of return when we make some investment at the present and anticipate a future stream of profits. So in this example, if we paid $60,000 now and expected to receive 5 equal payments of $8,000, then what would be the rate of return for that? So the way that we determine it is we discount the future revenues to times 0. So that is, we're kind of like moving the money through time. If you can think, you want to move the arrow towards the left and combine it as a single lump sum value. So if we would summarize that problem type in the convention that we've been using so far in the semester, it would be P/A, comma, I equals question mark, N equals 5. And then what we know is that A is 8,000, P is 60,000, and there is some I value that we could solve for either using Wolfram Alpha, or we could solve for it in our calculator or with Microsoft Excel. We could look up the formula for P/A. Remember that we have those formulas. I handed out a paper copy of it earlier, and I think it's posted also on Blackboard. So find P given A is this equation. So we would solve for I being the unknown. And in doing that, we're determining the interest rate. So there is some interest rate that makes the inflows and the outflows equal when everything is discounted to the same present. So balance between inflow and outflow. That's the overview of the problem-solving approach that we'll use a lot of times through the semester. Discount future amounts to the present, combine it with what's already at the present, and the net present value. By net, it means combining together the inflows and the outflows. There's some combination that will give us 0 at the interest rate we're looking for. So in spreadsheets, we can solve for the present value using the function I demonstrated in class on Wednesday, the PV function. And the PV function, when you start typing it into Excel, it gives you hints. Like it's going to give you little reminders of what belongs in each field. Back in the old days, like when spreadsheets first came out, you just had to memorize what went into each kind of space. But now they've realized that they can, if you hover over the equation, give you a little prompt as you start to type in the equation. And so equals is how you tell Excel that you're doing some sort of operation or equation. So in the cell you type in equals, and then it already knows to look for some sort of an equation or function. So equals PV, and then the rate that you should put in needs to be expressed in terms of a decimal. So if your rate is 8%, don't put in the number 8, because then it would think 800%. So for 8%, you'd type in 0.08. NPER means the number of periods. And remember that periods don't always have to be years. There are some problems where you've got monthly compounding or even daily. And so NPER, strictly speaking, means the number of periods. And for that matter, the rate that's here as the first term in the function needs to be the rate per period. And so if the problem statement tells you the interest rate per year, but then goes on to mention that compounding is monthly, you'd need to divide the rate per year by the number of compounding periods per month in order to get the rate per period. Okay, rate, number of periods. This third field, PMT, is what you would put in if there was a recurring payment of the same amount each time. So if you have an annual series, you can use the PV function and you'd put the amount of the A into that third field. But most of the time this semester, when we use the PV function, we're going to be using it in spreadsheets where each row is a different year. And when we do that, the amount for the row in question will be a future value. So you're going to hear me refer to like the double comma several times this semester. And so if you look over on the right-hand side of the slide here, after the N, there's just comma, comma. Having two commas in a row says skip over the payment. And so the amount that we're going to put into that fourth field will be the future value. So it's in brackets because it's optional. You don't have to have a future value in order for the PV function to operate. And type, that last area, is related to whether you have the end of period assumption or some other assumption. And so we'll always leave that blank because every problem I give you this semester will be based on the end of period assumption, which we've discussed before. All right, so any questions about the syntax of the present value function? Okay. So let's put that into practice, including the idea that a sign change always occurs when we use these financial functions. So let me do a demonstration. I have an in-class exercise for you later. This demonstration I'd like you to watch, and you can follow along if you'd like in Excel, but you don't necessarily have to. I'm going to solve two different cash flows. The first one, we've got, let me just do a print screen here so I can paste it into there. Okay, so we've got an interest rate of 10%, and we want to solve for the present value of an annual series. All right, so the A in our annual series is 8,000, and we want to find out what is the present value of that if I equals 10%. All right, so I'm going to use the PV function. Now I can, with the PV function, type the numbers directly into the equation. So see, it's prompting me here. It says rate in bold. So I could type in 0.1 as the rate. Now it's after the comma in bold, it's saying NPR, the number of periods. So I can type in the number 5 for the number of periods. Now it's asking me for the payment. The payment, meaning an annual recurring amount, a uniform series in other words, is 8,000. But because it's always changing sign on me, if I want to know the positive equivalent of a positive value, I have to override what it's going to do of flipping the sign by putting minus 8,000 and then close parentheses, and it tells me the present value is 30,326 and 29 cents. So that's with hard coding the values directly into the equation. But there's another way I could do it. I could have locations where I define the interest rate and the A and the N. And so here in this cell I could type in 8,000 for the A. I could type in 0.1 for the I, 5 for the N, and then let me do the PV function here, equals PV, And instead of typing in the values like I did in the previous one, I'm just going to click on the location where the value is. So for rate, I'll click here in B5, comma, NPER. I'll click where it's got the number 5 for our number of periods, comma. Now for payment, I need to say minus of this amount in the 8,000 and close parentheses. It's going to give me the same value, but the advantage of having this where the variables and the numbers assigned to those variables are outside of the equation is that if I wanted to change something, it's much easier, and I don't have to go into the formula itself where it's hidden most of the time. Like, for example, if I got back an improved estimate on my future revenue and it was maybe $8,200, I could just type in 8,200 and then it automatically updates this present value. So most of the time what we'll do, rather than hard coding the numbers directly into the equation, is we'll define variables somewhere and then we'll refer to those variables as we type in the PV formula in Excel. All right, so the other part of it, when you use Excel in your homework assignments, I think that you should answer the question in words underneath your table. So you're not making the grader go hunting for the solution, and you're making it very explicitly clear that you know the answer. So the present value is, now I got to change it back to 8,000. Okay, so answer, the present value is 30,326 and 29 cents for A equals 8,000, I equals 10%, and N equals 5. All right, and then maybe even just to draw the grader's attention to it even further, I could highlight that cell as yellow and highlight this. Here's my answer. So just think about the fact that what you're creating with a spreadsheet isn't just calculations, but it's communication as well. And people will sometimes, engineers love to share spreadsheets with each other, and I've gotten plenty of them. And some of the spreadsheets are really brilliant in terms of the calculations that are being done, but they don't put in annotations that would help you to understand what's being done. And so, like, you spend as much time figuring out how the spreadsheet is formatted and what goes where as you would have if you just made the spreadsheet yourself. So keep in mind that when you generate something like this, it's technical communications, and you need to put in the human touch so that it's really clear when you've been asked a question what the answer is. And it's not just a bunch of numbers in cells. All right. So that is the answer to question 1. Question 2, we have a different cash flow diagram. Solve for P. Oh, no, I'm sorry. Solve for P by putting 8,000 into the FV field of the Excel PV function. All right, so what I mean by that is there's year, amount, and then PV of amount. This is a table that we're going to see a lot of times this semester, and above it I'm going to define the interest rate of 0.1 because I'll refer to that. And so now I'm translating, let me do this top one first, just so that we see the same answer as we got with the PMT field. So I've got a cash flow diagram that I'm translating into a cash flow table. So nothing happens in year 0, then I receive 8,000. And rather than type 8,000 over and over, once you've got it typed in one time like this, there's this extra thick green block in the lower right. You can just grab onto that and drag it down, and it'll repeat the value so that you don't have to type it over and over. Okay, so equals PV parentheses, and it starts to prompt me. Okay, so rate, I'm going to click in this location. Now, when I drag the formula down, if I don't anchor the reference to cell B12, then for the next row, it would be looking here, where it says the word amount for the interest rate. There's relative references and absolute references, and I want to create an absolute reference to B12 so that it always looks there. So I'm going to put in dollar signs before the B and before the 12. So you can either type those dollar signs in manually, or you can just push the F4 button and it will put them in. Okay, so now, regardless of where I paste that formula, it's always going to look in this location for the interest rate. Okay, so NPER means the number of periods. So that means, in this case, the year that we're in, because what we'll want to do, for example, is we'll want to move this $8,000 5 years back in time to find out the present value. So the N that it's asking about is how many years back in time do you want to discount the amount in that row. Okay, so I'm going to put in the double comma to skip over the payment field, and then the minus of the amount should go into the future value field, because each one of these amounts in each row is individually going to be treated as though it's a future value. So now I don't have to type that same formula in over and over. I can do the same thing that I did in column B, where I just grab that thick green block in the lower right, drag it down, and it'll apply the same formula. Now, see how it's doing that? It just means it needs to be wider. So I got to make this a little bit wider. Now it has room to display all the values. Okay, so now I'm finding the individual present value of each $8,000 increment. And so it's interesting to see that the $8,000 in year 5, it only contributes $4,967 when discounted to the present, compared to the $8,000 in year 1 contributes $7,272. So the reason, remember, is that money in the future is less valuable than money now. And so therefore, money further in the future, like this $8,000 in year 5, if you discount it 10% each year that you're working it back towards year 0, it's going to be worth a lot less than these amounts which are earlier in the cash flow time frame. So now let's find the total. Equals sum, parentheses, and then with the arrow keys, I'm just going up with the arrow keys, and I'm going to start at the bottom, and I'm pressing Shift button and then arrow up to encompass all of those values. And so you'll see what it says is sum C14 colon C19. That means the sum of all the values in that range of cells. So enter the same thing that we had here, 30,326 and 29 cents. So you'll remember that I said this method of defining the variables is superior to typing them in, hard coding it into the equation, because it gives you the flexibility of changing the amounts. Well, the same thing is true with this table. This table is even better, because what if it turns out that some of the $8,000 amounts are a different value? What if it was $8,000 in year 1, $7,000, $9,000? So you can change the individual amounts, and this is able to respond anytime a change is made. It automatically calculates the new value. Okay, so any questions about what we've seen so far? So it's better to solve problems this way just because it gives you the flexibility of what if you've got a cash flow situation that's changing over time. So this is showing an irregular cash flow. And you couldn't, if you put the values here into the find P given A, it's not constant amounts, it's irregular amounts. So this approach of year amount, PV of amount, and then summing it at the end is a way to ensure you've got flexibility. Okay, so any questions before we go on? Okay, now the next function I want to tell you about is something called NPV. So you'll notice here we've got the equal sign, which is again the trigger that tells Excel we've got an equation or a function. So equals NPV, and that stands for net present value. So if you put amounts into that are only in the future, it will discount them to the present. And here I've got it in caps, underlined, and bold. Only put future values into that function. Don't put money into this function that's already at the present. Otherwise, you'll get an error. So let me show you how we could use the NPV function. If we have $8,000 every year and we want to find out the present value of it, here let me do the result of the NPV function. Equals NPV. Okay, the first thing it wants to know is the rate. We could either type in 0.1 or we can point it at a location where that interest rate is keyed in. So I'll do that. Here's the interest rate. I don't necessarily have to anchor this reference because I'm not going to be dragging the NPV function down through additional rows. Okay, now comma. The values you should put into it are only the amounts that are in the future. So it would be an error if I selected all of these values in the NPV function, because at year 0 there's nothing happening, but it thinks the first thing it sees is some amount in year 1. So it would give the wrong answer. Let me show you the wrong answer. I'll close parentheses and then push enter. We already know the answer is 30,326, right? It gives the wrong answer if we included 0 as the first value, because it's thinking this 0 was in year 1. So the correct way to use the NPV function is only include amounts that are in the future, and it will convert them to amounts in the present. All right, so 30,326 and 29 cents, and the way we did it was we put in the location, and it's reading it from top to bottom as year 1, year 2, year 3, year 4, year 5, and then it's automatically finding the present value of each amount and summing them together. So it's kind of completing all of the same tasks that we used in this full table in a single function, NPV. So it's useful. All right, let me hand out today's in-class exercise. We have a complicated cash flow diagram up on the screen. And the first thing you need to do is create a cash flow table in Excel. So in the handout it says create column titles year, amount, and PV of amount. So I'm going to be circulating around the classroom as you're working on it. Please raise your hand if you've got a question. I love looking at spreadsheets. I really am in love with Excel. So allow me to help you if you've got any uncertainties, if things aren't working the way they should. Just raise your hand and I'll take a look. You can watch me do it if you want to see the solution to this one. Practice makes perfect on these. There's no reason you should expect to be like really fluid with financial calculations on Excel if this is the first time you're doing it. And it's not going to be enough for you just to do today's in-class exercise and the homework. That's not enough reps for it to be like natural and really quick for you. So my suggestion is, see down here at the bottom where it says these sheets? Create a blank sheet tonight and then try and do the in-class exercise again and do it faster with no mistakes, just so you get the practice of how to do things and where it goes. You need the reps. All right, so that was the answer to the first one. If we go back here, it should be 78,260. And by the way, these videos that are posted on YouTube, you know, I recorded every click and keystroke as I was making the solution. And so, like, if you just got totally lost and forgot what was happening and why, watch the video tonight. And then that'll just kind of refresh your memory on how that one was solved. Okay, the last thing we need to talk about today is the F value, the FV function. So the FV function is similar to the PV function in its syntax. You know, we're telling it an interest rate is a decimal, number of periods. We will usually skip over the payment field and put in individual amounts into the present value field, and we have to put the minus sign. So a lot of it seems familiar. But if you think about what this function is doing, instead of discounting amounts to the present, it's compounding values some number of years into the future. So this is the kind of problem that we would use it for, where you'll notice here from the dashed line, we want to find the value in year 16. Now, at the bottom here, I'm saying we need one extra column I think for simplicity's sake, years until year 16, which is when our future value is, the amount, and FV. And the reason why is that for the NPER, the number of periods, you should use how many years it is until the future that you're interested in, and don't use whatever year you're in. So for example, if I want to take this 11,500 to year 16, what is the N for how many compounding periods it should be? How many years apart is that? It's 14 years apart. So if I said find the future value of this and I told it 2, it would only take it 2 years into the future. I need it to take it 14 years into the future. And so then that's why when we're creating a solution in Excel for this one, I'm going to have my interest rate defined at top here, and the interest rate value is in a different cell from the actual number. So the handout says the interest rate is 8.5%, so 0.085. Okay, now we have years until year 16, amount, and FV of amount. Okay, so the year is going to start 0 through 16. Years until year 16, I can either type it and have it detect the pattern and it'll fill in the rest, like that. Or I could have the equation equals 16 minus whichever year we're in. So there's a couple of ways to have this reverse time column. And now I have to translate the cash flow diagram into a cash flow table. So do that, 10,000, 0, negative 11,500, repeated 4 times. This mouse. Okay. Then nothing in year 6. Then 15,000 repeated 3 times. Then a nothing year. Then 17,000. A nothing year, negative 7,000. If you type in the wrong value, then obviously you're going to get the wrong final answer. So you have to be really careful and have some attention to detail when you're typing in the values. I'm sure I'll make plenty of mistakes this semester, but I'll try and catch them. All right, so we've got the amounts. Now for the FV function, equals FV parentheses. So it's telling us to define the rate. I'll click on the location, and then I have to anchor the reference. Anchoring the reference by pressing either the F4 button or type in the dollar signs themselves. Okay, now comma, NPER. Now this is where the mistake would be to click on year. We want to know how many years into the future that amount should be compounded. So I'm clicking on the reverse time column. Skipping over the payment field with the double comma, and then minus of the amount in the PV field. So it's going to tell me, for example, that $10,000 at year 0 compounds into $36,887 if you have it compounding at 8.5% each year. So if I move that money forward in time, it's going to get bigger because it earned interest. Now I can apply that same function. So you've seen me click and drag it down. Another way to do it is just double click. If you just double click on that thick green box, then it'll fill the entire value. And you know I don't like this red cell formatting. So here I can just select currency and it'll get rid of that. And I want to know what is the sum total of the future values. So equals the sum of all of these individual contributions to the sum future amount. And so let me put in my note to the grader. Answer. The total future value of this cash flow diagram is 3,820 and 67 cents. Okay. And just for good measure, to make it easy to find, I'll highlight it all in yellow. That's the final answer. That's the future value. Okay, so to review, the FV function is really similar to what we just did with the PV function, with the exception that the NPER it needs to see is how many years into the future is it being compounded. Not what's the number of the year that it's in, but how far into the future do you want to take it. So the N value that you put into the function should have how many years until the future. It's 12:49. We're out of time for today. Let me just review these announcements. Continue to bring your laptop. My suggestion is repeat this in-class exercise later tonight, maybe just to impress your friends on a Friday night. And, you know, you'll get better at it the more times you'll do it. The homework assignment's due on Wednesday, so I'll see you on Monday.